Hello, my name is Mike Wagers, and today we're going to cover a basic introduction to aerodynamics and the four forces acting upon an airplane during flight. What makes an airplane fly? Well, there's four forces that act upon an airplane in flight. We're going to refer to those forces as lift, weight, thrust, and drag. Here is once again is 172 with the four forces depicted: lift, opposing weight, and thrust, opposing drag. The four forces of flight: lift equals weight, and thrust will equal drag in steady state unaccelerated flight. Now, the term unaccelerated flight simply means, for example, when you're driving driving in your car on the highway and you're doing steady with the cruise control on at 75 miles an hour, that's a steady state condition. And when you see the police officer and you hit the brakes to slow down to the speed limit of 70 miles an hour, well, drag will initially overcome thrust until you reach the speed limit of 70 miles an hour, and then at that point in time you are in a steady state unaccelerated condition, and thrust will equal drag again. What does it take to create lift? Well, first you need air in motion. And how can we explain lift? Well, we're going to use Newton's laws of motion, and Bernoulli's principles are used to explain lift. First, let's take a look at this Venturi tube. Bernoulli first used a Venturi tube, was doing some experimentations with air. And some of the things where you can see a Venturi used today is a carburetor uses Venturi to mix the fuel-air mixture for an engine and things like that. But Bernoulli's principle states as velocity increases, pressure decreases. As you can see here, air flows into one end of the tube, and then when it gets into the restricted area, the velocity increases and the pressure decreases, and then once again it returns back to normal on the other end of the tube. You can see this in several examples every day, and we'll get into some of those here in a second. But now, if you hold two sheets of paper together, shown here, and you blow between them, no matter how hard you blow, you cannot push them more than a little apart. This is simply due to Bernoulli's principle. The faster moving air on the inside creates an area of lower pressure, and the higher atmospheric pressure pushes them together. Same thing with the ball here. The atmospheric pressure is higher than the lower pressure of the air flowing around the ball, therefore creating what we call lift. What is a wing? Well, if we dissect a Venturi tube, we can see that a wing is nothing more than really just half of a Venturi tube. Bernoulli's principle states that as air speeds up, pressure goes down, and as we can see through this pictorial view, the actual wind that moves up and over the top distance of the wing has more distance to travel than the air flowing over the bottom, therefore creating a lower pressure. Once again, here's another example that you can use to see that. For blow across the top of a piece of paper, it will rise due to the faster moving air creating a lower pressure. And once again, here is a pictorial view over the wing, and the thickness of the wing pushes the air up and over, therefore creating a lower pressure on top of the wing. And once again, here is another picture showing you the same example. Now let's talk about Newton's three laws of motion. An object at rest wants to stay at rest. Force equals mass times acceleration, and equal and opposite reactions. Well, as we can see here, as if we've flown a kite before, hopefully in our childhood we all have, as air hits the bottom of the kite, it's deflected downward. Now the upward motion of the kite is called lift, and that is also the equal and opposite reaction of the downward deflected wind. Once again, here is some definitions that you should have defined already. The chord line is simply the imaginary line from the leading edge to the trailing edge, and the relative wind is the wind that you create when you're in motion. Like you're riding a bike, the wind is in your face. That's relative to your motion. Now this angle is called the angle of attack. Now the more angle of attack, the bigger this gets, the bigger lift gets. And we'll see that here shortly. And once again, here is a picture of Bernoulli's principle and Newton's third law in action, how they both work to create lift on a wing. The air moving faster on the top creates lower pressure, and then the deflected wind downwards, equal and opposite reaction is therefore lift. And as we can see here, as this here showing the camber of the wing is the thickness of the wing, how thick it is. The thicker the wing, the more distance the air has to travel. So the faster it has to go to meet the wind in the back, therefore creating a lower pressure on top of the wing. The angle of attack, or basically how much the pilot pulls back, is directly related to how much lift you produce. The more you pull back, the more lift you get, up until a certain point. And here's some pictures of pressure distribution along a wing, you can take a quick look and see that the higher pressure on the bottom two wings are underneath it, therefore creating lift. And in the negative angle of attack, it creates a little bit of higher pressure on the top, making the aircraft want to fly down. Factors that affect lift. Here are some functions that, an equation that engineers use to create lift. But as you can see here, the only thing we can manipulate as a pilot is the angle of attack. We can pull back and make the aircraft go higher, or we can go faster. Okay? There are certain aspects of the wing that we can use to create a bigger surface area, but those are all a little bit more complex for what we're wanting to get at here. Here we have what is a stall. When we're talking about aerodynamics, a stall simply means something ceases to exist. In this case, we're referring to lift, where the engine does not stop in an aircraft when you stall it. What happens is this air flowing over top of this wing starts to separate, creating a disruption of the smooth airflow. So what happens then at that point is you pull back on the yoke, you get more and more lift, more and more lift until the wind cannot flow over top of it anymore. Therefore, the wing is no longer creating any lift, and that is called a stall. Different wing planforms are used for different things in aviation, as you can see here. So how does the pilot control lift? Well, as I said, angle of attack, we pull back, it goes higher up until a certain point where the wind can't flow over top of the wings. Then that's detrimental to its performance. Airspeed, angle of attack and airspeed, and high lift devices. We're going to take a look here at flaps, and what flaps do is when they are deflected downward, what happens is it changes the chord line. The trailing edge goes down, therefore increasing the angle of attack, allowing the aircraft to come in at a slower airspeed to land. And here are the different types of flaps, and as you can see here, some of these that move down and out like these two actually do increase the surface area of the wing a little bit, allowing for a little bit more lift. And that's what we'll end it here. We're going to take a break, and I'll see you here shortly on the next one. Thank you very much.